is I will explain you the concept of apparent depth. Okay, and this is related to the internal refraction which happens from a denser to rarer medium. Okay, so I've seen a lot of students are confused about the topic of apparent depth versus the real depth of the object which is lying inside a dense medium. I'm going to draw a diagram, not a very great diagram it is going to be, but it will help you retain that concept forever. So irrespective of complexity of the question you see, you should be able to solve this apparent depth problem. So let's start drawing the diagram and I will explain you how you need to memorize it. Okay, so let's say this is your bottommost surface in which you have a liquid, and the container which you have is this. Okay, so this is your container. Okay, this is your container, and the liquid is this is the liquid. Okay, so we are talking about a liquid which is a dense medium, and the total height of the liquid, okay, let's call it some value of say x. So that's your total depth of the liquid. The object which is inside the liquid is somewhere here. Okay, so this is your object, and we have to find how high will it rise up because of the concept of ray optics or refraction. Okay, so let me now start explaining you what's going on in this situation. Okay, the idea is to explain you the concept and ensure that it gets ingrained in you. Okay, so a ray of light, draw a ray of light which is straight. Okay, perpendicular, right? Any ray which is perpendicular just passes through. As simple as that, right? So this also too, even though it's a denser medium and you have air, from a denser to rarer, it goes straight because it is at right angle. Okay, now the second part is important. So you send out a ray in this direction from the object. This is your normal. This is your normal. The ray bends away because the ray is moving from a denser to rarer medium. There is no concept of critical angle, total internal reflection, nothing. It's a pure case of refraction, Snell's law, nothing else. What is the key in this question has to be understood. Now what we do when we have refracted it, we pull this ray back, and now the same object which was residing at the bottom appears to be located here. Okay, that's your apparent depth. Let me just mark it for you. So this is your apparent depth. So what was so deep inside right now is only y. Why? Because of refraction. This is the basic of the concept of apparent depth. It occurs because of refraction. Okay, now how do we solve these questions? You need to know a bit of geometry. So let's say you strike this surface at an angle of I, right? Now this is a normal. Remember, this is a normal, right? And this too is a normal. So these two angles are equal, right? So this is a normal. Okay, so this is a normal, and these two are the angle of incidences, right? What is this angle? Okay, this is your refracted angle. Snell's law. You apply Snell's law here. So the point I'm exhibiting right now, okay, this point, one of the things you will do is apply Snell's law, right? And when it comes to the geometry, let's understand the geometry. If this is your angle I and this too is your angle I, then this is a refracted angle, right? And this is I. What is this? This is your refracted angle. Let's try and do some math here and see, if we can argue on the triangle. So let me just show you the triangle. This is triangle. So this triangle which I'm showing you now, this is of interest to us, and the smaller triangle which is of interest to us is this one. Okay, so there are two triangles we are talking about. So let's say this is A, this is B, and this is C, and this is D. So the two triangles your focus is on the triangle ACD. This is your one triangle. Then the other triangle you're talking about is BCD. Okay, there are two triangles we're talking about. And we have already established that these two angles are equal. These are alternate angles. Simple, right? But we need to go beyond this and try to understand what more can we identify, because we know the angle of incidence. Can we really think through what are the other angles? Okay, so let's say what could be this angle, right? So if this is your R, okay, this is your R, this is your angle. Can we get something in angle of refraction? Because my ultimate goal is to worry about Y, and then I have to worry about X, right? Now if I use these two triangles, I can get, right? So if I want to write, for example, okay, so this distance is Z, okay, where the image gets created. Let's say this is the, so if I want to write tan of I in the triangle ACD, see the triangle ACD, I want to write the tan. How do I write it? It will be Z by Y. So I'm talking about triangle ACD. No brainer, right? Similarly, what I want to do is I want to write the apparent depth, which is sorry, I think it is Z by X. Sorry, I'll just rub this off. So this is Z by X, the tan, right? Sure, you identified this mistake. So this is X, and let's say we are talking about the smaller triangle, right? So the smaller triangle is BCD. The smaller triangle is BCD. Can we write that too in terms of tan of something? And then I write, I'm talking about this angle actually, right? So the base is, the perpendicular is Z, but the base is Y, right? So if I can show that this angle by any chance is same as I, okay, these two will give me something, right? So let's see. So this is R, which is with, and this is an extended R, right? So how much is this angle? Okay, so don't worry about my diagram, because the line which I extended is for this, right? So I can draw a straight line like this actually, right? So this is one and the same thing. Sorry, the diagram doesn't look good. I already warned you. It's not going to be a great diagram. Let me redraw the diagram for simplicity. Okay, so I will just extend this back. I will extend this back. So this angle and the angle which is being made with the this angle, and I think okay, so with the horizontal, if this is R, how much is this? This is 90 minus R, right? To balance. And if this is 90 minus R, how much is this? This is 90 minus R. So at least I know one angle. And what is this angle then? This is R, because it's a triangle, right angle triangle, right? So the triangle BCD is a right angle triangle. So first we focused on R, and then we looked at the normal and the this was a refracted ray. The refracted ray makes an angle of 90 minus R with the horizontal. Okay, so where is the horizontal? We are talking about this horizontal. Okay, so don't worry about that Snell's law. I know it's a bit messy, and okay, so this is the way it looks. This angle was R, this is 90 minus R. The opposite angle is also 90 minus R, which I have labeled already. And so this was your opposite angle, and then this is a right angle triangle, so this is R. So can I write tan of R is equal to Z by Y, right? I can, absolutely. So this is my real depth, and this is my apparent depth. Should I divide them? Yes. So tan I upon tan R is equal to Z upon X upon Z upon Y is equal to Y upon x. Okay, so we have established a relationship between the angle of incidence and the angle of refraction. But the point is, we said we will use Snell's law. Okay, now Snell's law is all sine I upon sine r. Okay, so we can also write sine I upon sine r as approximately equal to tan I upon tan r. Okay, if we do this, then my tan I by tan r becomes sine I upon sine r is equal to y by x. And what is this, by the way? Okay, this is your refractive index of the medium, right? The incident angle and the, but this is from denser to rarer. Obviously, it will give you 1 upon mu. Okay, so because we are talking about something else here, we're not talking about the usual refraction that happens from, because the entry is happening from rarer to denser, whereas in this case the entry is happening from the denser to rarer, right? So y by x actually has to be written as 1 upon mu, and therefore x, right, which is your y, which is your apparent depth, becomes equal to x upon mu. So if you know your depth, the real depth, right? If you know the real depth, you divide it with the refractive index of the medium, you get the answer of the apparent depth. So this object, which is located here at apparent depth of y, is the way to solve this is the apparent depth is equal to the real depth divided by refractive index. So the point was, if you understand a bit of geometry here and the angles that find, and this particular aspect, right, this is very interesting. If you ask me, the sine I upon sine r approximation to be tan I upon tan r is a mathematical tool. If you use this, it's a shortcut to getting the answer without converting sine and tan into tan I can be converted into sine I with the help of a triangle, and tan r can also be converted into sine r using a triangle, but this is a shorter way to solve it. Okay, so I hope this concept was clear. Don't be scared of questions where you see apparent depth and all that. Whether there are 2 mediums, 3 mediums, 4 mediums, you need to know this diagram at every interface. Also, what you have to do, apply the Snell's law finally, right? So each layer will play its, supposingly this question has many layers of liquid. Each layer has a refractive index with respect to the other one. So whatever ray, if the ray is coming from a medium whose, the real depth is known and the refractive index is known, in that medium apply this and bring the object up. That will become the apparent depth. And that apparent depth now is the real depth for the next liquid, and so on and so forth. So you can write that up. I will show you how to do such questions where you have multiple layers. No great shakes, nothing great about this. This is straight vanilla derivation, straightforward. Important thing, if you understand the geometry of those two triangles, and you understand that I have to apply Snell's law, I think 90% of the job is done. It's just about being able to handle 1 or 2 complex questions on this topic, and you're done with. So I hope you enjoyed this video about the concept of apparent depth and how do you derive it or address it when it comes to problem solving. Geometry, 2 triangles, some approximation of sine I by sine r, and then of course the knowledge of Snell's law. That is a final, so to say, the mission, right? We want to get mu and sine, because if you want to get the answer in refractive index, the apparent depth gets calculated in terms of real depth and the refractive index of the medium. So I'll show you the question where you have multiple layers. Wait for my next video. Don't forget to subscribe, because our channel is giving you comprehensive explanation of the concept. We're not just mentioning or articulating the concept. We are actually going in depth, explaining you so that it gets retained forever. Once you listen to this, it stays with you forever. Thanks a lot.